Good. So what I was telling that this is the size of filter, which is 3 by 3. If I increase the size, looks like that I have more parameters. Looks like that I will be getting more things. Is it better to have more things? Looks like that it is better. But we are using smaller one. Why we are using smaller one? This is again a very interesting thing to know. Actually, what happens that is this thing we call as a sparse correctivity. Okay, by having the CNN, what is going to happen that you can think that if you have an image, first row, then second row, then third row, if you cut out those values and put one by one, you are going to get a from this 2 cross 2, you are going to get all these values side by side. On this, you are actually applying a filter. Filter would be applied if it is filter 2 class 2 filter is applied on these four values. You can think that it is connected to only these four values. Then the next value is coming from these four things. So you can safely assume that there is these are again a neural network, neurons which are connected with a very few items, not with all. I wanted to say that if you connect all this, because this neuron was in this kind of setting, it is only connected to the four. If I connect to the more neurons, it is going to be better. But this actually introduces more number of parameters, and it becomes very difficult. And this is the only reason that the people were not able to train beyond the four number of layers. So beyond four layers, people were not able to train because they were doing this mistake that they were actually combining everything with all the things. So this new deep learning arena introduces the CNN and tells that I would be connecting to only few, and their weights are shared. So number of weight is only 4. And I have also achieved something as a layer. So this is the advantage that this CNN is going to provide. Uh, but what about the data? Because here we are having the loss of features. Essentially, what is going to happen that because I'm not telling that use only CNN at the first layer. Next layer also you can put the CNN. Then again you can put the CNN layers. 16 layers, 8 layers we are going to put. Okay. So after 8 layer, what is going to happen? That okay, this thing was only connected to this one, but this one is actually connected. Somehow it is connected to all the things. When you go big above, so they are actually somehow connected to all the values that are inside. So at the end, you are going to get complete understanding of the data with the lesser number of parameters. And because of this, you are getting good result despite having the sparse connectivity with respect to the into the neural network. So this is an important thing to know that deep learning in the deep learning arena, very important thing is that to have the neural networks, to have the CNNs, they have having the lesser number of parameter by introducing more number of layers, they can produce the similar kind of results. And as we rightly understood this, that the parameters are lesser because their parameters and weights are actually shared. All right. One more thing that sometimes what happens that if you have an image and you apply a filter, you are going to get an output. Sometimes this output can be made better if you just select the best value, because the highest values are actually the things which are actually happening into the system. Okay? If you see in any of the block, the value that dominates is going to be more important in taking the decision. Okay? Because some value is higher, its contribution to the decision is going to be higher as compared to the value which are actually lesser. So you can again apply some more technique, that is max pooling, mean pooling, and average pooling, that tells that out of these four values, out of every four values or 16 values or 9 values, you are going to pick the highest value and going to tell that. Okay, for example, here, out of these four values, I am going to, if it is a max pooling, I am going to use only 8, one value, because out of these 5, 8, 7, and 6, 8 is the highest. So I can, from this, I can reduce the feature size. Again, why I want to reduce the feature size? Because number of filters I am going to increase so that the different kind of features can be obtained, and then I can combine them, them into the better. So there are three important concepts. One is cooling, and another is stride. What is stride? Stride is that sometimes you want to hear itself mix the thing. For example, out of these four values, you got one value. Then the next value can be obtained by putting the filter here, or putting the filter here, or you take it more forward. So this is called the stride. So with the filter and stride, you can adjust to see that what is the best size for you so that you can get the better result. Very important thing that number of parameters, when the number of parameters are less, you have to do the lesser number of computations. So these are the small technical details that actually are there. Okay. Okay. So yes, just give me a second. All right. So this is the paper I was talking about, 1997 I mentioned, 1998 paper, Linet. This architecture was given in 1998, and this takes a 32 cross 32 image, and that image contains a kind of digit. So you know that on postcard you write 1, 2, 3, 4 pin number. Somebody has cut this 1, 2, 3, 4 part and put it as a database. Okay, in one database, in this 32 plus 32 pixel, there is either 1, 2, any kind of number is written on there. I feed it to this network. So can you tell me what is that? Filter are 5, 1, 2, 3, 4, 5. You can see every filter creates one plane. So there are how many filters? 5 filters. Stride is 1, means for all values you are going to get that. And there is padding is 0, there is no padding, therefore the size reduces. And by this you get, from one image you get 6 images. Is it fine? Okay. How many parameters we have here? How many parameters we have? It is telling the filter size 1, 2, 3, 4, 5, 6 filters. Filter size it is telling 5 cross 5. So in 5 cross 5, how many values are there? 25. How many such filters are there? 6 filters. 25 into 6 is 150 different parameters. So 150 parameters are here. And what you get? 28 cross 6 something. 28 cross 28 cross 6. Then it is going to apply 2 cross 2 filter. How many? 6 filters. 6 such filters. Every filter is going to generate how many? Every filter is generate one plane, 6 filters. So again you get the 6 values, 6 different things. Yes. Filter size is 2 cross 2. How many values it has? 2 cross 2 filter has how many values? 4. But it have to be applied on this because this deck has a 6 thing. Na? So 2 cross through, or how many are there? Are 6 planes are there. Na? 2 cross 2 cross 6. So these many number of parameters. How many parameters are there? 2 cross 2 cross 6 cross 6. What is the value? Here it is 0 parameters because this is a pooling layer. Pooling layer means what? The values of whatever values are there, you are going to get what? One value. And maximum, because it's a max pooling or min pooling, whenever pooling is written, understand it as a max pooling. So does max require any parameter? It does not require any parameter because चाहे जितनी वैल्यूज मुझे दे दो अगर मैक्सिमम है मुझे पता है क्या करना है I will sort find out the maximum so there is no parameter as such so number of parameters is 0 then again there is a filter this filter is convolution layer 2 and the convolution layer there is a filter which is size this is the convolution layer 2 filter size is 5 cross 5 how many parameters 5 cross 5 cross 6 5 cross 5 cross 6 and how many of them are there 16 so 16 multiplied by 5 cross 5 cross 6 so 2400 parameters then again I am going to apply a pooling so there is no parameter So how many values I have now? Size keep reducing. It is 5 cross 5 cross 5 cross 5 cross 16. So how many values are there? You see, and then there is a fully connected layer. Fully connected layer are actually the classification heads. They give you the classification. So 120 neurons are here. Every neuron is going to be connected with all of them. How many are they? 5 cross 5 cross 16 multiplied by 120. So these many number of parameters are here. Okay. Sometimes one is also added to that because the bias term is also added over here. So this you see the calculation. What is that? Then there are next fully connected layer where 84 neurons are there. All of them would be connected because it's fully connected. All of them would be connected to the previous one. Every one is going to be connected to 120. So 120 multiplied by 84. Okay. So this is the number. And then last 10 are connected with 84. So it is 85 why I told you that for every one there is one more connection it can be given to bias. So 81 is connected to 85. 84 are these plus one bias. 85 multiplied by 10, these very number of parameters. So by this you can estimate that how many parameters are there, and we have gone to this that how earlier gone to this particular slide earlier also that initially people were using histogram of gradient, LBP, linear binary pattern, SEM, etc. And their accuracies are very less, but deep learning has increased it very large. So what was the architecture? Architecture was this. This architecture is called LX. How many layers it has? I told you the 8 number of layers it has. Okay, let us see. Going in this, going in much detail with this is not that much required. That actually, what is the value that is not such important. We should understand the concept and how they are related with each other. Okay. So people actually think about this that initially you get the features, lesser number of feature, but at the later point of time you do more mixing on the features. Okay. Initially you can see that he has applied a filter of 11 plus 11. Okay, how many filters? 96 filters. Then did the max pooling. So max pooling is not considered as a layer because it does not have parameters. So the first parameter layer, second, third, fourth, fifth, sixth, seventh, eighth, layer. Right? So after getting this, you apply a max pooling so that lesser number of processing you need to do. Then you apply 256. Why? Because you want to do more mixing of the features. Then again do the max pooling. Again do the different kind of mixing. 384 mixing. Then again 384. Then 256. And then do a max pooling and then 4096. Then 4096. And then there is 1000. Why 1000? Because yes, because there were 1000 classes, 1000 classes in this database. Okay, so with respect to the every class, there is a neuron. If it says n, one means it is of that particular. So if multiple object can also be there in one image, person having apple means apple and person both are there. So more than one neuron can tell one value. Okay, yes. Next slide. Yeah. Previous. Okay. This.
The filter is like that small gray right?
Here we have a filter. Yeah, yeah.
That's the convolution layers.
Correct, correct. And this is the filter. Yeah, this is.
And that size 28 to 28 is for the convolution layer.
28. Look, 32 cross 32 I have, but if I apply a filter of size 5 cross 5, so my size becomes 28 cross 28. How? My size reduces. So, as
that's what I'm getting. Like, the filter size is 5 cross 5.
Correct.
So, like with one sprite, the sprite value is 1. So, we are taking like from 5 pixels, we are taking one value.
One value, huh?
So, that is how it becomes 28.
Correct.
So, the filter is that small gray area. Right?
Yes.
And in different layers, the filter is different filters.
In different layers, the filter values are different.
Like in convolutional
correct.
Layer 1,
yes. Yeah.
Convolutional layer
with respect to this, filter values are different.
So the weight associated with that filter, or the inside, like earlier you said, na, in a filter, if we take value 1 1 1 0 minus 1, then 1 0 minus 1, then 1 0 minus 1. So weights are associated with the that filter or with the value 1 0 minus 1. 1 0.
Okay, 1 0 minus 1 is actually the weight.
It's a filter.
It's a weight. Filter has it. This is the weight.
Okay, so we update the value of the filter set.
On the image, there is some value. In our previous example, all the values were 150. So these are the image values. My filter has 1 0 minus 1, 1 0 minus 1, 1 0 minus 1. These are the weights. These values are weight. Okay, these values are weight.
So
if I want to get filtered output of this image, I would multiply it with this, get one value. So out of these 9 values, I would be getting one value. Okay, but I can get second value. I can just shift it one pixel, and then again 9 value, where 6 values would be already present in the previous one also. So with them, I can create one more value. So how many values I can create? I can start from here, but I cannot go till in. Before in, I would be stopping. 5 values, before 5 values, I would be stopping. So this actually says that filter size minus 1, I have to original size minus filter size plus 1 is the size of views. Because you have to stop. First value you get the value, but the last you will be stopping over here. So filter size minus 1 values would not be available. F minus 1 values will not be available. So there is a formula.
Actually, like when we imagine like that neuron diagram, right? Like there are 5 neurons in the input layer, and in the hidden layer there are supposed 3 neurons. So like we make that circle diagram, right? So each of that, each of that neuron is kind of a filter, and weight is associated with that connections. So is that thing a different weight, and the filters value are different weights, so are those also combined?
Weight and filter values are same. Just I'm telling this. Okay. Weights means the strength of values.
So there's no weight value with the connections.
That is the value. Because look, let me go to the previous one. You are here, here. Okay. Try to understand this one. Okay. This is a neuron. This neuron is not connected to everybody. You are here. It is not connected to everybody. It is connected to with the only 4, and all of them are at a different place. If I would be putting any other place, this connection would be different. So you can assume that there is a weight. You can assume that there is a weight which is inside that particular table. Am I able to tell you?
Yes. So basically, one of these filters will decide that what class this image is from. Or combined.
Look, this is actually not going to give you say, one output, no? Because this is going to give you output, multiple output you will be getting. If you set one thing, multiple outputs you will be getting. For every pixel, you are not telling that. No? So the output, the final output, you will be getting after applying this fully connected. So this part that you are talking about is only here. But final output, to get the final output, what is the class, you have to put a fully connected head classification head here. So the output that what this item, what class this item belongs to, for that you have to put a fully connected head. Yeah, am I able to tell you? Filters have this. If my filters here, you can see that k is equal to kernel size. Kernel size is how many kernels? 6 kernels are applied. Filter size is 5 cross 5. 25 values are there. Those values are going to be applied at different places. I am going to get another feature done. Second one because 6 we have. First could be blurring. Second could be the edge enhancement. Third could be edge extraction. Something else. Different things are possible. So, all right. Okay. ठीक है. So now we were here. We were seeing what is LXNet. So as I told you that LXNet is has 8 number of layers, and we are going to only count those places where there is a parameter. Max pooling does not have any parameter because we know that only out of few values I am going to take the max pooling. Why we do max pooling? Two reasons. Whatever is important I am going to collect and reduce the number of processing. Okay, and this is what the structure is. Need not to go into much detail. More than this, you should understand only this part that initially 96, then 256, then 256, then 384. I am going to increase because I want to do more mixing of the features, developed features. At the end, there is fully connected. As I told you that the next person came, that is a ZFNet, that told that instead of using 11 cross 11 here, if you put 7 cross 7, you'd be using the lesser number of parameters and your accuracy can increase. So he have proposed a different architecture where there is a difference in the total number of parameters. A lot more parameters are here also. So 1.45 million parameter are lesser in the LXNet, and ZFNet has more parameter. Okay, this is LXNet, this is ZFNet. Any special observation? Again, you can see that 96, 256, 512, 1024, 512, and then 4096, 4096. Okay? All right. Any question? Okay. So at the end, what happens now? At the end, what happens that if you increase the things over here, so this number of parameter here increases too much. So that's why at the final layer, sometimes you want to do a consolidation so that you save the number of parameters over here. Because यहाँ पे जितना बड़ा होगा, everything is going to be connected with everything. So that's why it is something like that. Okay, next architecture was we thought about that instead of using 8, use 16 or 19. This is the other architecture, BGG 16 that actually has 16 layers. Can you see 16 layers? 16 layers. So places where there is a parameter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, nothing fancy. Only thing is this uh, that they have always used the kernel size to be 3 class 3 because now they are having more deeper architecture. So as I told you that two things, if 3 class 3 above 3 class 3 you again put 3 class 3, so first one looks like 9 class 9. It already become very bigger. So this is the architecture. Nothing fancy on that. ICLR 2015 paper. It's very intuitive, na? Very simple. Next architecture, inception rate. That tells that you see the things at different sizes. so so what it does that it applies different size filters. Few minutes back I told you that if you put the bigger filter, you are actually seeing the bigger thing. Smaller filters seeing the smaller things. Different kind of filters, 5 cross 5, 3 cross 3, 1 cross 1, different kind of filters and max pooling. You combine all these things, put at one place, and then take it from. Okay, this is called the inception block. However, this is one part only. It actually one more things. It also introduces one thing that is called the one cross one convolution. Because when you are putting multiple things at one place, what happens that this D, this depth becomes very high. Number of parameters, if number of filters you increase, this increases. Okay, this increases. So more processing is required at the later point of time because he had to do a computation with all of these items. So this architecture also introduces something called one cross one convolution. It says that I am going to find out the linear combination of all these items and put it here. So One class one. This is the one class one correlation that actually here into the previous slide it was actually mentioned. Huh. So here one cross one was written, na? One cross one. This one cross one does what? That this is a big thing. D is a big thing. It try to reduce it so that the number of processing is actually less number of processing is required. Okay. So this is one insertion block, and it has one class one convolution, one class one convolution, three class three max pooling. Then after three class three max pooling, one class one convolution, five class five, three class three, and then concatenate all these values and take it from it. So nothing more than this is required. Just try to understand this part that having this kind of architecture is actually introduces a lot more parameters. There was in the previous architecture, we have always seen that at the end there were two 4096, 4096 things. So this 4096 into 4096, in between lot of connections were there. Just see that 4096 multiplied by 4096, how many zeros are there? So three zeros, six zeros, and seven zeros. So those many 1 into 7 zero number of parameters are there inside. So he has reduced those parameters, so removed one of them and taken all the processing inside. Okay, all the processing inside. Because number of parameters he has increased in a huge number inside. So you can see that 64, then 192, then 256, then 480, then insertion blocks 512, 528, 832, 832, 1024, and then average pooling, then dropout. Again, he is introducing something more important, that is dropout also. 40% of the values he had dropped out, and then used 1000, 1000, then after again 1000. So this number of parameters, there earlier 4000 parameters were there, 4000 plus 4000 parameters there. So from the classification heads, he had introduced the parameter inside and definitely got the better result. So this is what the Google event. Does it make sense? तो अगर आप देखेंगे, if you see from the very high level perspective, तो जैसे मैंने कहा ना कि सिर्फ किसी भी चीज को देखिए तो अलग अलग साइज से देखिए, उसके अलावा भी बहुत चीजें करनी पड़ेगी, क्योंकि नंबर ऑफ पैरामीटर उससे आप बढ़ा लेंगे फिर आप कंप्यूट नहीं कर पाएंगे, यू नॉट एबल टू कंप्यूट. To solve that issue, what other changes need to be done? Number one, 4000 became 1000, one layer has been removed, and even here when the values were there, 40% values are actually dropped out. Okay. Dropout बड़ा विचित्र मामला है. Dropout किसको पता है क्या है? Dropout. Dropout जो है बहुत जरूरी चीज है कि उसमें क्या है कि जैसे हमारे पास वैल्यू है, उसमें हमें बेस्ट वैल्यू चाहिए, मान लो 10 वैल्यू है आपको और 10 वैल्यू में आपको बेस्ट चाहिए, बट आई एम टेलिंग यूज ओनली 9, रेंडमली एक वैल्यू में मिक्स कर देगा. मोस्ट ऑफ द टाइम आपको मैक्स मिलेगा, कभी कभी नहीं भी मिलेगा. उसका फायदा क्या होगा? उससे बहुत डिफरेंट काइंड ऑफ फायदा मिलता है, डिफरेंट काइंड ऑफ फायदा मिलता है. आपने वो जैसे जेनेटिक्स में लोगों ने पढ़ा होगा, म्यूटेशन एक चीज होता है ना, बीच में अचानक किसी एक चीज को हम फ्लिप कर देते हैं, जिससे वो खराब भी हो सकता है लेकिन अच्छा भी हो सकता है, और जब वो अच्छा हो जाता है तो बहुत फायदा करता है ना. इस तरीके की चीज है ये. ड्रॉप आउट जो है इलेक्ट्रोलाइजर है, जो कि सिस्टम को दैट एक्चुअली हेल्प्स अस टू मेक द सिस्टम बेटर फॉर द नॉन सीड आइटम्स. ओके, बिकॉज़ फॉर द सीड आइटम वी हैव मेक द थिंग्स समथिंग बैड. All right, so what was the next architecture? Very important feature, 12 times less connection as compared to LXNet. LXNet से भी कम connections है इसके पास. 2 times more computation as compared to LXNet. Does more computation and very high accuracy. Okay, this is what the parameter is. Next thing was ResNet. And ResNet was याद है कितने इसमें 150. कहाँ अभी लोग बात कर रहे हैं 8-16, ये टॉकिंग अबाउट 152 मोर लेयर्स। तो उससे उसका आइडिया बड़ा सिंपल है। उसका देखो ऐसा है कि if something happens in 5 layer and if I apply 6 layers, okay, that's just going to happen. Something can be developed using 5 layers. I apply 6 layers. Whether the network will be work perfectly or not, because I know that I believe on the network कि network can be trained. अगर network trained हो सकता है तो 5 वाले को train हो जाएगा, next वाले को 1 कर लेगा, है ना? वो सारी वैल्यू 1 कर लेगा, they are just passed out, passed away, because I believe that network can be trained using back propagation. Network can be trained. If the network can be trained, so network would train 5 layers and next layer would be 1. If I apply 7 layers, same thing. So for any problem, if I don't know that how many layers I should apply 100. मुझे पता है यार 100 तो बहुत easy, 100 is a very large number, definitely my work would be done. It's a very large number, my work would be done. This is what the concept is. It says that if something can be done with these number of layers, if I increase few layers, so they would definitely only pass these values to the next layer and my task will be done. And I believe the network can be trained. ये इतना सिंपल कॉन्सेप्ट है। रेजनेट इसलिए 150 लेयर 150 लेयर लगा देता है और उसके बाद ट्रेनिंग स्टार्ट करता है। कहानी उसके बाद शुरू होती है। कहानी उसके बाद शुरू होती है। कहानी इसके बाद शुरू होती है। क्या है भाई? एरर रेट है ना? इधर की तरफ एरर रेट है, इधर की तरफ इटरेशंस है, और when we have 20 layers, this is the error rate. Okay, when we increase it 32 layers, what we are expecting, ज्यादा लेयर बढ़ाने पे क्या होना है? इस पे रहेगा या उससे कम करेगा? ये तो गलत, बट ये तो ज्यादा एरर दे रहा है। 44 लेयर किया और ज्यादा, 56 किया और ज्यादा, क्या मामला हो गया? बोलो दिस स्टफ आप देख रहे हो, जबकि होना नहीं चाहिए ऐसा। What I told you, if something can be done with 5 layers, if I apply 6 layer, I believe on the back propagation. सब लोग believe करते हैं भाई। So if everybody believes on this technique, so this should work. So it should be at least at the same level. It cannot go up, but it is going up. तो so problem हुआ। अब वो problem क्या? Problem ये हुआ कि back propagation train कैसे करता है? सोचना पड़ता है। Back propagation किसी चीज को train कैसे करता है? How back propagation works? Back propagation tries to find out the gradient. At this level, what is the gradient? And it goes against the gradient so that error, because gradient tells you what is the direction. If you go in that direction, the value is going to increase. You go to the negative direction of that thing so that your error reduces. It does in that way. Means if this value is working, nearby value should also work. Okay, it believes in concept. It believes that if some value is working, nearby value should also work. Something they are better or wrong, but I would be go to the better direction because I know that what is the gradient. I will go to the better direction so that I will be better. This is the underlying assumption of the back propagation. But in our case, what we decided few minutes back, if something works on the 5 layer, if I put the 6 layer, it passes the value. Passes the value means 1. If instead of 1 I put 0.9, will it be working? Remember that. If 5 layer network that is working, if I am going to put another layer and वहां पे जो connection है उसमें 1 के अलावा 0.9 आ जाए या 1.1 आ जाए, चलेगा वो? नहीं चलेगा। आप समझ पा रहे हैं मेरी बात? तो जो the fundamental requirement of that back propagation has an issue. That's why it is happening. After increasing, क्या कहना चाहता हूँ मैं? After increasing the number of layers, things are not that straightforward. They have error, they have problems. If I increase this straight away, increase the number of layers, things are not going to work. Earlier हमको लगा था करेगा। अब क्या करूँगा? तो फंस गया। नंबर ऑफ लेयर इंक्रीज नहीं कर सकते। आइडिया हमारा वही था, यही हमें लगता था ना। अब देखिए यहाँ पे इनोवेशन आता है, दिस इज व्हाई द पेपर इज इम्पोर्टेंट, दिस इज व्हाई द पेपर इज इम्पोर्टेंट। आपने जो थोड़ी देर पहले मैं आपसे जब वो पूरे प्रोग्रेशन को डिस्कस कर रहा था, आपने कहा कि हाँ सर नेटवर्क का लेयर बढ़ा देंगे, एक्यूरेसी बढ़ जाएगी, हमने करके दिखा भी दिया। अब आप देख रहे हो कि अब आपने एक्सपेरिमेंट उसका डाला, एक्सपेरिमेंट में आप देख रहे हो कि गड़बड़ हो रहा है, आप फंस गए, आपको लगता है कि आपका कॉन्सेप्ट ही गलत था। अभी तो यही लगा ना, कॉन्सेप्ट गलत नहीं था, उसमें कुछ और करना पड़ेगा जिससे कि वो कॉन्सेप्ट चले। जहां पे आती है ना कि आप क्या करते हो, आप कैसे फिर से वही चीज कर लेते हो, कि आप कैसे फिर से वही चीज अचीव कर पाते हो, हाउ यू व्हाट यू आर गोइंग टू डू सो दैट यू कैन अचीव द सेम काइंड ऑफ थिंग्स वंस। व्हाट instead of 1 can I use any other value in the 6th layer? ये तो requirement है। How can I do that? I can do that by introducing something called the skip connection. Here I want the specific value 1, but if I connect the previous layer with this layer, then if this is not 1, then something can come from here and that can make it 1. Because other layer is learning, it can change its parameter, so that summation becomes 1. My value is not 1, but because of the skip connection, some value that is coming from the previous layer, it can provide me some value so that my summation becomes 1. And here the nearby values would be working because he can change the value. Nearby things are working. So this is very important. That it introduces something called skip connection. What? Skip connection. ये उसका सबसे important बात है. उसने पेपर ने ऐसे किया. Now he has proposed that this architecture that I was thinking, instead of this, I am going to have the skip connections. Okay, I am going to have the skip connections. Correct? And by this, the network was able to be trained. Okay, the 152 layers deep neural network of ResNet was better than the human, and it has the error of 3.6%. It is better than the second best system on ImageNet detection. You can see that. So second best से वो 16% अच्छा था, ये second best network था, उससे 16% अच्छा है. और if you consider the localization thing, it is where the item is 27% on the COCO database, and on the segmentation it is 12% better. So this is what I wanted to tell you, that this is what the result is. Okay, got the idea? Okay. There are specific hyperparameters that if you Xavier initialization, SZD, and so many things, so that is not important. Next task, one more architecture that I wanted to see about that. This is a problem where this is a high definition image taken from the microscope, and we wanted to tell that these are the one item, the second item, or where are the boundaries. This task is called the segmentation. So ISBI challenge, there was a challenge open, and as I mentioned, that electron microscope slides were there, and the person had to do this particular task. So this was the architecture proposed. This architecture is called unit. Very interesting kind of architecture. Let me just tell you that what this architecture. It looks like U, but essentially inside things are connected. What is the important of this architecture is this: whatever size is input, similar size is going to be given as an output. Okay. There are 2-3 operations that image actually cropped. It is taken smaller and then applied 2 kind of filter. Then again cropped. Again applied 2 kind of filters, and this kind of, you can see that there is a convolution operator of 3 class 3, and so convolution of 3 class 3, then convolution of 3 class 3. Then this operation is copy and crop. This part is cropped and sent over here. This is the match pooling of 2 class 2, therefore the size actually reduces. Again, here the size reduces, your size reduces, then 3 class 3, 3 class 3, 3 class 3, and by this you are going to get what? Segmentation. अब आप कहेंगे कि सर इससे segmentation कैसे हो जाता है? How you get the segmentation? So, so answer is I believe on back propagation. I believe on back propagation, and in the process, I have done something so that I get the very small size 1024 size representation of the same image from which I can reconstruct everything. So from the big image, if you extracted something and that can generate the similar kind of thing, means what very important thing has actually you have actually extracted, and then if you propagate the same thing, so 1024, why 1024? Because it's a very easy multiple of 2. So it is again going to give you the output, and again you can propagate and find out that what is the corresponding pixels and things. So very high accuracy, and it has this architecture has achieved the IOU, means how much overlapping the actual and the prediction is 77% as compared to the 46% of the second one. So other people were able to do only 46%, and this model was able to do 77%. 2015 paper. Okay. Very phenomenal paper. And then comes this very interesting paper. I think everybody must have heard about this. You only look. Okay. So YOLO is interesting problem. YOLO solves a very interesting problem that in an image, where is the object? Okay. Object has classes. This is the dog, this is cycle, and this is truck. So how to do that? Object detection, any idea? How can we do that object detection? If a big image is given and I want to do the object detection, so the method should be that a big image is given to me. I will divide the image into equal parts. On every part, I would see that is there a cat, is there a cat, is there a cat, is there a cat. The places where I see one, so those things I can just match. I can get here is a cat. Okay. But the question comes, what should be the size of this block? Okay. What should be the stride? All these things are very difficult to decide because if total number of possibilities I see, they are nearly infinite. So there was a very interesting lineup of solutions that came, okay, at that time before that. And those solutions, again, people were actually using deformative part modeling. They think that if, for example, if there is a cat, so cat, if there is a person has a hand, person has a head, person has a body, leg. So they can be deformed. Just try to see that is there a hand, is there a leg, is there a head, and they can be combined in a very different way. And if you can combine them and make something like human, then you say that this is human. So this kind of model has accuracy of how much? There is a specific database, a Pascal database that is called 33.7% accuracy. Next year, a model came that is called the regional CNN, RCNN, and this says that I am going to divide the things into region. For those regions, I am going to find out the features, and then I apply the classifier. Accuracy was 66%. Jabardast model. Then comes the fast RCNN. It says that features, it combines features and does the things on the features also. So the accuracy increased to 70%. Then faster RCNN. It again applies some kind of changes. Okay. Faster RCNN has two kind of architecture using backbone as a VGG, backbone as a ZFnet. They have accuracy 62% and 73%. So these results are produced by the same group. When they come up with RCNN, it was a big hit into the research community. That is the things which has the accuracy of 33%. Now we have accuracy of 66%. Then they increase this 66 6% to next year to 70%, and after that they increase it to 73%. Okay, forget about this. This just tells that you can set up VGG and use data flat particle. But they're and they are becoming faster also. So 7 frames per second they can process. Then comes the UNO. UNO is very simple architecture. It says that you don't get the thing complex. If you have big thing, so divide this into 7 plus 7. 7 plus 7 means 49 different things. So earlier what you were doing that you are applying detector here, here, here. So how many times you have to apply the detector? For every block you have to apply the detector. 49 times you have to apply. But if I say that inside image you put 49 detector itself, even the image, after that you apply 49 detector itself inside. So within 1 unit of time you will be able to get all the result. This is the important thing. That it applies 49 different parallel detectors at the same time. So by this you get this kind of output. It looks like that there is a dog. So if you know that there is a dog, then and there are a few more things that I just want to don't want to cover in the interest of your don't confusing you. That if there is a dog, I can just find out the bounding box. I can tell that dog is here. Okay. Here the cycle is, so I can find out. I can tell the cycle is inside this particular region. If there is car, I can say that car is inside this region. So it is fast. Why it is fast? Again, is it any magic? No. I have divided the image into equal parts. For every part, I have applied so many parallel things. That's why I am fast. So this UNO has 45 frames per second processing power. So that's why it is nearly real time, and accuracy is little bit lesser because it is more correct, less accurate, but it is fine. Sometimes it is fine. Also do some kind of error, it is fine. Latest is UNO V9, and it is very fast. You can by yourself run and see that how the things is happening. Okay. So I think I am done with this. So I have tried to cover some of the important architectures that actually deploy the CNNs and do the object detection, do the feature extraction, do the classification. Any questions if you have? I think I have taken 45 minutes up with much. You will forgive me. Any questions? Yeah. Like online participant, do you have any question?
So why the one
Why? Yeah.
all your friends jumps to online with teacher?
Yes, he would also jump because statistically it is happening, na? All the friends are jumping, so he will also jump. Okay. So this is what the statistics is really. Okay. So just a look. Anything else? Everybody is jumping, so you will also jump. You don't think it is good or bad. So data happens like this. Okay, data happens like this. Behind everything, there is only one thing prevails. That is statistics. Okay, statistics says it is happening, then it is happening. Okay. All right. Thank you very much for being wonderful audience. Thank you, everybody. Thank you. I think the next session would be in your lab, so you can move to the lab.
For online participants, the next session is going to be held in the lab. So please stay with us in the lab.
ग्रुप फोटो बात करेंगे या फिर वो भाई से बोल देंगे
All the participants are requested to get assembled at top this room or a group photograph.